Okay, I will record the video. F and H.
Where's my good pen? Ten. Oh, 1 minus 5x is 1 10 1 minus 5x negative half dx.
Oh, you should not have spent too much time on these two questions, by the way.
Yeah.
Are you done?
No, not yet.
Oh, okay.
That's the messenger's to answer. Cross, and then with times 1. Okay, for question F, right? So does it? So it's negative minus 5x. Does the when you take it out, is it negative 1/5?
Yep. So when you differentiate, so you are supposed to take out the negative 5, right? So
Yeah.
to counter the effect of this negative 5, so you should have negative 1/5 to counter the effect of it.
Right.
Yeah. Okay. So are you done with question F?
Almost.
Okay, good.
that's question F. Question WH is 4, 2, 3 minus 4x. Dx is 4, 3 minus 4x, negative half is plus 3. Negative 4, negative 2, 3 minus 4x plus c.
Are you done?
Yeah.
Okay. Please send it over. I would say these two questions are very similar.
Yeah. Okay. Send.
Okay, good. Let me take a look at it again. Okay, good. So for F, right? So let me do it my way and then compare. Then you can actually compare my way of doing this question to your way of doing this question. Okay, so over here, you should use chain rule, okay, to solve the following questions. So for question F, what you need to do first is you should change this to the power of half.
Yeah.
Okay. Then after that, what you do is then you start the integration by adding 1 to the power, and then you bring down the resultant power. Of course, you have your 10. You have your 10, so you just put it outside, and then you know that when it comes to differentiation, your negative 5 will be taken out, right? So you need to counter the effect of this negative 5.
Okay.
Okay. So this times, and this is an indefinite integral. So you have to have a plus c. So after all this, you are supposed to get negative 1 minus 5x half plus c. And that's it. So like I say, the c here is a constant. Okay? So let me check your answer.
It's 2 times 2. How is it?
Pardon?
It's 10 times negative 1/5, right? And it becomes negative 2. Negative 2 times half.
So over here, you're right. So basically, you're talking about here, right?
Yeah.
So I am supposed to get minus 2. Minus 2 is 2. So I'm supposed to get minus 4. Right?
Yes.
Yeah. So this should be the answer. Okay?
Yeah.
Yes. So this is the answer. Okay? Yeah. So over here, this is divided by half. So divide by half, that means you should get 2. Okay? Yeah, good. So over here, so you do the same thing. You change this to a negative index first. And after that, you start your integration. Okay?
Right.
What you do is take out the 4. Okay? And then over here, you add 1 to the power. And then you bring down half. And then you know that when it comes to differentiation, the negative 4 will be taken out. So you need to cancel the effect of it by having minus 1/4 here. Okay?
Right.
So what you get is negative 2. 3 minus 4x half plus c. Okay? So this should be your answer for H. Okay, good. So you get both correct. Okay, good. So we can move on. Okay, so let's move on to other questions. Question 2. Okay, we'll demo with one of the questions and then you will carry on from there. Okay, so let me pick 2V. Okay, so over here, for this question, I will highly suggest you write down the differentiation. You write down the differentiation of some of the special trigonometry functions first. Okay.
Okay.
So write down the differentiation of trigonometry functions first. Okay. Okay. So when you differentiate your sine x, you get sine x, right?
Yeah.
And then you differentiate this, you should get negative sine x. Differentiate tangent x, you should get secant square x. Okay. Okay. So therefore, if you integrate, then you are supposed to get from the right hand side to the left hand side. And if you differentiate, you are supposed to get left hand side to the right hand side. Okay?
Yeah.
So right now, you are having what? You are having this 2 cosine bracket minus 4x. So what you can do here is you can differentiate term by term.
Okay.
Okay? So for these two, you can take it out first because it's a constant, so you can take it out of the integration. Okay, so therefore you can start to integrate. So cosine minus 4x. So cosine, where's cosine? Cosine is here, right?
Yeah.
Okay, so when you integrate cosine, you are supposed to get, so basically when you integrate this, you are supposed to get sine x. But since over here you have minus 4x, so you should have minus 4x here, right?
Yeah.
So you integrate, so basically look at this. You integrate your cosine, you're supposed to get sine x. So you integrate your cosine minus 4x, so you are supposed to get sine minus 4x. And you should know when you differentiate your this, you will have your minus 4. You will have your minus 4 taken out, right? So what you need to do is you need to have the 1 minus 1/4 to cancel the effect of that. Okay? So therefore you see I have a minus 1/4 here. Okay? And then that's it. Okay? So this is your answer for this part.
Okay.
Now you can go ahead and do integration of 1, which is x. Okay? And of course, you should have a constant as well, because we are talking about indefinite integral here. Okay? So if you simplify it, you're supposed to get this. Okay? So this is your answer for 2B. Okay? Okay?
Okay.
Good. So I will pass on to you to try out 2G and I.
G and
Yes.
I.
Yes. And I. You can see my screen, right? Can you?
Yes, I can see your screen.
Okay, good. So this will be the formulas you need.
Yeah. Okay. So it's cosine 2x, right?
Yeah.
Is it
Mm-hmm.
cosine 2x? When I integrate,
Mm.
do I need to like do the half, put the half in front?
Oh yes. The reason is, so let's talk about just a simple one. Let's say cosine 3x, right?
Yeah.
So when you integrate cosine 3x, we are supposed to get sine 3x, right?
Yeah.
According to here, right? So am I right?
Yes.
Yeah. So you know that when you integrate, when you differentiate your this sine 3x, your this 3 will be taken out, right? So you need to have 1/3 to cancel the effect of the 3.
Right.
Okay. So yeah, that's it. So plus C.
Okay.
Okay. Okay. So similarly, you should do the same thing for sine 2x. Yeah, once you are done, send it over. I will just demo the question 2i. Are you done?
No, not yet.
Okay. You should be doing 2i.
Yeah, I am. Uh, Hmm? You have taken a bit of time. Can we start? Send it.
Okay. Okay, good. So I will just go through 2i. Okay. So you just, for this question, you differentiate term by term.
Good.
Okay. So for this, the half, you can take it out of the integration sign. The 3, you can also take it out. So it becomes super simple. So
Okay.
cosine x, you're supposed to get sine 8x. And you know that when it comes to the differentiation of sine 8x, you're supposed to take out the 8, right? So you need to have your 1/8 to cancel the effect. Okay?
Okay.
And then over here, you integrate sine x. So minus sine x, you should get cosine x. So over here, sine x, you're supposed to get cosine x minus cosine x. Okay? And then after that, plus c. So after you simplify it, you should get this. Times is plus. Okay? So this should be the answer. Okay? We check. Okay. How come you have sine x over 16? Okay. You started with cosine 8x, right?
Yeah.
Yeah. You look at your answer. Your answer is sine x over 16. Can you see your answer?
Yeah, is it wrong? It's supposed to sign 8x over 16 now.
Yes. Okay.
Okay.
And plus, I think your presentation, like I say, the presentation of your answer is also needs to be a bit careful about that. Okay, the reason is, okay, if you look at your answer here, so this is clearly wrong. So you're supposed to sine 8x, okay? And of course, then you're supposed to have your plus c, okay? Because we are talking about indefinite integral here. So you're supposed to have this plus c here. Okay, good. Okay, so in fact, I saw this question, 2e,
Right.
which is also quite interesting. Okay, so how do you solve 2e? Okay, because instead of just one term, 2x, you have this plus pi over 6. So
Okay.
how do you solve this question? How do you solve this question? Okay, so I hope you still remember. So let's take a look at 2e. So to do this question, okay, what you need to do is you take out the 2 first, because the 2 can be taken out of the integration sign. So what you do is you just differentiate this. Okay? Okay?
Yeah.
So how do you do this? Now you have 2 terms. Are you going to do this? Just okay. So since integration of sine x, you will get cosine x. Okay. So therefore, cosine x will give you minus sine x. So you're supposed to have minus cosine 2x plus pi over 6. And then you know that when you differentiate this whole thing, right? When you differentiate this whole thing, your 2 will be taken out. So you need to have your half to counter the effect of it. Okay?
Right.
Then plus c, because we are talking about indefinite integral here.
Okay.
So you end up with minus cosine 2x plus pi over 6 plus c. Okay? So this is one way to solve this question. Okay? This is one way to solve this question. So I'm going to show you another way to solve this question. Okay, I'm going to show you another way to solve this question. So let me get this one out of the way first. By the way, this will serve as a reference. Okay.
Yeah.
Next, I'm going to show you the next method to solve this question. Okay, over here. So you can actually do this. You can actually change your this. You can actually open the bracket. Okay. So you have sine 2x cosine pi over 6 plus cosine 2x sine pi over 6. Can you remember this? How do you open the bracket? Means this whole thing will be equal to this. Do you still remember this?
No.
It comes from this sine A plus B.
Oh.
And you're supposed to get sine A cosine B plus cosine A sine B. Okay? It comes from this. Okay? So with this formula, so things become easy. So just open the bracket. Cosine pi over 6. You can use a calculator, which is what? Cosine 30 degree, right? So cosine 30, you get this. Okay?
Yeah.
And then 2 times cosine 2x, sine 30, 1 over 2. Okay? And then what do you get? You get square root 3 sine 2x. And then cosine 2x. Right? Okay?
Right.
And after that, you just differentiate this term and this term separately. Okay? You just integrate this term and this term separately.
Okay.
Okay? So when it comes to this, so this question is like the other questions. Okay? Okay? So this is another way to solve this question. Okay? So you have both method 1 and method 2. Okay? Can or not? Can we move on? Can we move on?
Yeah.
Okay. Good. Okay, let's do question 3. Question 3 is a question which you need to make use of the concept we have learned so far. Okay, so let's do the question together. Okay, so first thing first, it says part A, it says we have this y equals to fx, given that the dy dx is this, and that y equals to 11 when x equals to 8. Okay, so what it means is you have a function fx, okay, and then the differentiation. So basically, when you have dy dx, right, what it means is this is your gradient function.
Right.
Okay, so let's talk about the meaning of differentiation. Okay, we talk about the methods to do integration and differentiation. So right now, let's talk about the meaning of them all. So let me give you a very simple question. So let's say you start off with this graph function, y equals to x squared, okay? And then when you differentiate this, and you are supposed to get 2x, right? Okay.
Yes.
When you differentiate this, You are supposed to get 2x. So what it means is, this is your point x equals to 0. So let's say this is your point x equals to 1. This is your point x equals to -1. Okay. So if you are asked to find the gradient function, can you see it? If not, thicker. Okay. If you are asked to find the gradient function at this point, x equals to 1. So you can actually make use of this gradient function to find out what is the value of the gradient here. So if you make use of this gradient function at x equals to 1, you're supposed to get, at x equals to 1, you're supposed to get 2 times 1. So this means the gradient for this line is, gradient is denoted by which letter, by the way? M, right?
Yeah.
Y equals to mx plus c. So this small letter m is your gradient, right?
All right.
So over here, you make use of the gradient function at x equals to 1. So you put it into it, you should get 2 times 1 equals to 2. So this means your gradient for this line is actually 2. Okay? You are making use of the gradient function to find the gradient for this line. Okay? So similarly, at x equals to -1.
Right.
So you get -2. So this means you make use of the gradient function here. You make use of the gradient function here. And your this the gradient of this line okay, the gradient of this line is -2. Okay, so you are making use of the gradient function to find the gradient of these two lines. By the way, these two lines are also called the tangent. Okay,
Okay.
tangent to the graph. Okay, so this is your tangent at x equals to 1. This is your tangent at x equals to -1. Okay, so let's say if you don't know how to use the difference, you don't know how to use the gradient function, because before we learn differentiation and integration, we don't know how to do differentiation and integration. What methods allows us to find the gradient of the tangent? Can you still remember?
No.
Can you remember?
No.
Hmm? Can you still remember?
The tangent.
Yeah, the gradient of this tangent. If you don't know how to make use of the gradient function.
I only know how to use the gradient function.
Okay, so let's assume that you have not learned differentiation and integration. So how can you get the gradient of this tangent? Okay, there is another method. Okay, so let's go back to the fundamental. Okay, so you have this curve, then you are asked to find the gradient of this line. Okay, given that this is your at x equal to 1. So how do you find the gradient of this line? Okay, to find the gradient of the line, there is a formula. Okay, the formula is y1 minus y2 over x1 minus x2. Can you still remember this?
Yeah, right.
All right. So that means if you don't use your gradient function, let's assume that you have not learned differentiation and integration, then you should use this formula to find your gradient, okay, for this tangent, okay? So so what it means is you just need to pick 2 points. So probably you pick this point. This point is your 0 and -1. So let's assume that is the assume this is the coordinate for this point, and then you pick another point. So over here is, so y equals to x squared. So this point will be your 1 and 1, right?
Yeah.
Okay. So you just take these 2 points, and then you can find your gradient. So y1 is 1, y2 is -1, right? And then x1 is 1, x2 is 0. So you have 2 over 1. So your gradient is 2. Okay? So your gradient is 2, right? For this tangent at x equals to 1. So let's look back at this. At x equals to 1, yeah, your gradient is also 2.
Yep.
Okay? So this means in order to find the gradient of any tangent to the curve, there are 2 methods. Okay? One of them is you make use of this gradient function. Okay? And the other one is you use this formula.
Right.
Okay? So now let's go back to the question. Okay? So the question here says, let me use empty slide. Okay? So you have a gradient function here. So just now, for this curve, you differentiate this, you get your 2x. So now you are given this gradient function. So in order to have your graph function, what you do is you need to integrate your gradient function so that you get back your fx. Am I right? So this is your graph function. This is your gradient function.
Yeah.
How do you get gradient function? You differentiate. Okay? You differentiate, you will get your gradient function. So from gradient function, how do you get back to graph function? Okay? What you do is you integrate. Okay? So therefore, to get back your graph function, you need to integrate your gradient function. Okay?
Right.
So to integrate this, first you need to change it to this format. Okay? So once you change it to this format, so you add 1 to the power and then bring down this resultant power, which is 2 over 2. And you know that when you differentiate this, you will take out the 2, right? So you need to have half to counter the effect of it. So basically you end up with 3 2x minus 7 and then 3 over 2. Okay? Plus c. Okay? Let me double check. So you should flip it. Okay, so you are supposed to have 1/3. So basically this times flip it. So you are supposed to have 1/3. So I'm supposed to have 1/3 here, not 3.
Yeah.
Okay, let me change it. Okay, and then you are supposed to have your plus c. Okay, so right now you are supposed to find your plus c, or you are supposed to find your c. How? You are given that when y equals to 11, x is equal to 8. So that means f8 is equal to 11. So with this, what you can do is you have this 2 times 8. You put in your 8. plus C, you're supposed to get 11.
Right.
Okay, so let's simplify it together. So this is 9. Okay, 2, 8 is 16, right? 16 minus 7 is 9. So, yeah, you get this. Okay, so let's do this together. So over here, you are supposed to get 3 to the power of 3, which is 27. So 9 plus C is equal to 11. C is equal to 2. So your C is equal to 2. So your this graph function is supposed to be this. Okay.
Okay.
Okay. So this is your graph function. Okay. So you have solved 3A. Okay.
Yeah.
Yeah. Now let's move on to part B. Okay. So to move on to part B, let me use a blank page. Okay. For 3B, it says you have a function which has a gradient function of this. So similarly, graph function, you differentiate to get this, right? So to get back the graph function, you need to do integration. Okay. So what you do is you integrate this. So to integrate this, you change it to this format first. You can take out the 4. So add 1 to the power and then bring down the resultant power. And you know that when you differentiate this, -1 will be taken out, right? So you need -1 to cancel the effect of it. Okay? And then you end up with plus C. So -4, let me tidy up a bit. Half, so it means you times 2. So times 2, this. Okay, so this is your graph function. Okay, so then it says what? It says it passes through these 2 points. So what it means is your f -3 should give you -11. So therefore, you just put in your -3. You are supposed to get -11. Okay, so that's 8, 1 plus, so it's 4. So square root 4 is 2, so it's -16. Minus. So C is supposed to be 5.
Right.
Okay. So therefore, your this graph function is supposed to be, so this is your graph function. Okay, so this is your graph function fx. Okay. So now the question asks, find the point on the graph with x coordinate -8. So you just put in your -8.
Okay.
So -8, so this is 9. So square root 9 is 3. So it's -24 plus 5 -19. Okay, so that's the y coordinate of this. So now the question asks for the point, right? So therefore, your answer should be the point is, so -8 and -19. So this is your answer. Okay. You know what's the difference between a point and you know what's the meaning of a point, right?
Yeah.
A point is defined by, this point is defined by your x and y coordinate. Okay, so that is the reason why when they ask for the point, I'm supposed to give them in coordinate form.
Okay.
So that means you shouldn't stop at here. You shouldn't stop at minus 19. Okay, because they ask for the point. Okay.
Yeah.
Yeah. So that's the meaning of the point. So the point is defined by your x and y coordinates. Okay. Okay.
Okay.
Okay. So let's have a 5-minute break, and then we come back and we'll continue. Shall we?
Okay.
Okay. Good. So I will stop sharing and mute my video and voice. Okay, I'm back. If you are back, just let me know. Hey, I'm back.
Hello. Hello.
Okay, I'm back. Good. Can you hear me?
Yeah.
Okay, good. Let's continue. Okay, let's move on to the next question. Okay, so okay, over here, question 4, using the identities to help you integrate with respect to this. So you see, so over here, right? If you look at question 4, let me get it to the slide first. Okay, so can you see over here?
Yeah.
So if this statement is not there, how do you do integration of this? Okay, probably what we do is we will do this, right? So this is actually equal to this,
Right.
right? What we will do is we will just do it using chain rule. So plus 1 to the power, bring down the resultant power, and then that's it, right?
Yeah.
Oh, by the way, I make a mistake. Because you integrate cosine, you are supposed to get sine, right?
Right.
And then you see, when it comes to this, the question you ask yourself is, you need to differentiate this okay, when it comes to differentiation of, let's say, okay, let me just do it normally. So I just do it normally, sine
Yeah.
x to the power 3. Let's differentiate this. Okay, so you bring down the power, and then power minus 1. And then you have to differentiate this sine x, right?
Yeah.
So when you differentiate sine x, you get cosine x. So can you see you end up with what? You end up with 3 sine square x and cosine x.
Okay.
Now, when you integrate this thing, okay, you use the similar approach, power plus 1, and then bring down the resultant power. And then the question you ask yourself is, when you differentiate sine x, you are supposed to get what? You are supposed to get cosine x here, right?
Yes.
So are you going to do this?
No.
Are you going to do this?
No.
Because when you differentiate sine x, you are supposed to get cosine x. So you need to have 1 over cosine x to cancel the effect of cosine x. That is the logic behind chain rule. Okay. But in this case, you can't do this. Okay?
Okay.
Can't do this. Okay? So therefore, when it comes to this type of question, you need to make use of identity, which is given here. Okay? So this means what? This means if you have trigo to the power of something, you cannot use, okay, you cannot use chain rule.
Right.
Okay, you need to use what? You need to use identities. Okay, so how do you use identities? Okay, let me demo to you. So let me get rid of this. So this cosine square x is equal to half plus half cosine 2x. So in this case, you just differentiate. I mean, you just integrate term by term.
Right.
You can take out the half. Okay, so now this is your trigo to the power of 1. So you can do the integration. Okay, so integrate half, you get half x. And when you integrate cosine 2x, okay, if you still remember, you are supposed to get sine 2x. And then you know that when you differentiate your this 2x, the 2 will be taken out. So you need to have half to cancel the effect of the 2. Okay. So, and plus c. And then you should be getting this as a result.
Yeah.
Okay. So remember, when you have trigo to the power of more than 1, you cannot use chain rule. Okay. You need to use the identities over here. Okay. So I will pass it to you. So please try out D and F. Okay. Please try out D and F. Can you see the questions?
Yes.
Okay. Let me get it to the new slide. Okay. D and F. Oh, by the way, do you know what you are supposed to get for this term? What you are supposed to get for this term?
I don't.
Hmm?
I don't.
So you just make use of this. So if this is a x, right, this will be 2x. Okay. So right now it is. So right now is what? It's 3x, right? So you should get 6x. Okay. Okay. So yeah. So you just need to integrate this. Okay.
Okay.
I will pass it to you. You just simplify this and then continue the integration. Are you in your room?
Yeah.
Oh, looks like you have a big room, huh?
No, I don't actually. This is the wall.
Yeah, you have a big white wall.
That's not a very big wall.
Okay.
I am compromised to sit on my bed with a bed desk because the actual desk is not big enough.
Okay. So you are sitting on your bed.
Yeah.
Wow. Okay.
Well, it's not really a bed. It's a mattress on the floor.
Okay. So are you doing? Are you having our lesson sitting on a mattress on the floor?
Yeah.
Okay. I'm doing the lesson in our living room.
Okay.
Okay. Yeah, I will pass it to you. Okay. Then you continue to do the integration for this. Are you done with question 4D?
Does it need to be, I don't know, the 2.5, does it need to be integrated?
So if you simplify, you're supposed to get this. Okay? Then you just integrate term by term. You can actually combine this so you get 2.5, or rather 2.5. Okay, so you just differentiate these two. Okay?
Okay.
So are you staying in your room most of the time?
Yes.
Wow,
Okay.
good, not good. Go to the gym. Go out, exercise.
It's not open. I do run every day.
Okay. So for this question, you're supposed to get 2.5x. So you take out the half, so you should get this. So you simplified it. That's what you are supposed to get for 4D. Okay, do you get this?
Yeah.
Okay, good. So for this question, F. So how do you do F? So what you do is you need to open the bracket first.
Yeah.
Okay, you open the bracket first. Okay, so once you open the bracket, you just differentiate term by term.
Right.
Okay, and the first two terms, you shouldn't have any problem. The third one, you need to make use of the identity here.
Yeah.
Okay, so that's the technique. Okay, to solve this for F. Okay, so shall we move on?
Yeah.
Okay, good. Okay, let's take a look at a question. Okay, let's take a look at 11. Okay, for 11, the differentiation for exponential function is this. Okay, this is the differentiation of exponential function. Okay, so let's take a look at this question together. So you are asked to find the graph function given your gradient function. So you need to integrate your gradient function. Okay? So you can actually take out the 2 out of the integration sign and just integrate e to the power of minus 2x. And you just look at this. When you differentiate ex, you get ex. So when you integrate ex, you also get back ex. Okay? So I integrate, I should get back the same thing. And you know that when you differentiate this thing, your minus 2 will be brought down, right? So you need to have your minus half to cancel the effect of it. Okay? So now, let's see. So you should get negative. Okay?
Okay.
So now, it says F0 is equal to 3. So therefore, minus 2 times 0 plus c is equal to 3. E to the power of 0 is 1, right?
Yes.
So minus 1 plus c equals to 3. So c equals to 4. So you put it back, your fx is equal to 4. Okay? So we have finished part A. Okay, part B, similar technique. Okay, let me go to the next slide. So you integrate your gradient function, then you get back your graph function. So I integrate one by one, term by term. So over here, power plus 1, bring down the resultant power. Okay, I hope you still remember when you differentiate ln x, you will get 1 over x. Okay?
Right.
So therefore, you make use of this to do the integration of the second term. So therefore, you are supposed to get, so the 2, you can take it out. Okay? So here you simplify, you get x to the power of 2 minus 2. So over here, you are supposed to get this. Okay, and you know that when you differentiate this thing, your minus 1 will be taken out, right? So you need to have minus 1 to cancel the effect of minus 1.
Okay.
Okay, so therefore you get this as a result. So this is your fx. So they say f minus 1 is equal to 3. So you put minus 1 into it. Minus 1. Minus 1, so it's ln 2 plus c. So here is 1 plus 2 ln 2 plus c is equal to 3, right? So your c is equal to 3 minus 1 minus 2 ln 2. Okay, so let me use my calculator. 3 minus 1 minus 2 times ln 2. Okay, so the answer is not exact, so it's 0.614, 3 significant figures. Okay, so therefore I put back my c into it. So this is supposed to be this. Okay, so this is my graph function. Okay, so far so good. So far so good.
Yeah.
Okay, so let's move on to part C. So let me go to the next slide. So it says a curve has a gradient function.
Wait, I need to go to the toilet real quick.
Okay, sure. Let me know when you are back.
Hey, hello. Hello.
Okay, welcome back.
Uh,
Okay, good. Let's continue. Okay, let's continue the last question. Let's see. Okay, so you have a gradient function. So you need to integrate the gradient function to get back the graph function. But before you can integrate this thing, okay, you need to put it in a format that is friendly for integration. Okay, then you integrate one by one, term by term. So you add 1 to the power, bring down the resultant power. Okay, then over here, when you integrate this, you're supposed to get this. And when you differentiate, your -4 will be brought down. So therefore, you need to counter the effect of your -4 with -1/4. Okay, so C. So this is your fx. So you simplify it. So -1/8 plus C. And then it says it passes through 1 and 0, right? So you just, when it's 1, you get 0. So you put 1 into it, you're supposed to have, you'll get this. Okay? So you get 2/3 times 1, so it's 2/3. So e to the power of -4 times 1, so it's -4 plus C. So just solve for your C. Okay, so I will do it here. Okay, so let me use my calculator. We have 2/3 minus 1/8 times e to the power of -4. Okay, you are supposed to get this. So your 0.664 plus C equals to 0. So your C is -0.664 to 3 significant figures. Okay, so now it says find the equation of the function. So the equation of the function is you put the C back. So which is here. So the equation of the function is this. Yeah. So this is the equation of the function.
okay.
Okay. Okay.
All right.
Good. So let's move on. Okay, over here it says show. Okay, this is okay. Over here it says integration by substitution. Okay, integration by substitution. So let's take a look at one of the question. You have u, okay, and then this is du dx. So get this. Okay, good. Let's take this as an example. So we are moving on to a new method called integration by substitution. Okay, so to use this okay method, you need to be able to see that this term and this term are actually linked. Okay,
Right.
how they are linked? Okay, you can see that if you differentiate this one, you will get 2x plus 3, right? Okay.
Yeah.
So it's only this one is valid, then you can use integration by substitution. How? So if you let u be x squared plus 3x, okay? So what do we have is this one replaced by this whole thing replaced by u. And then this is your du dx, right?
Yeah.
Okay, so then you can solve it. Okay, so what do you get? Can you see that this dx and dx, they cancel each other? Because it's times. Okay,
Yes.
so ultimately what you do is you just differentiate this thing. So what do you have? You integrate this, so power plus 1, bring down the resultant power. So you end up with this. Of course, you need a plus c. Okay, so that's it. So your u is equal to this. So you just replace by that. So yeah, that is the method. Okay, integration by substitution. Okay, it only works if this is valid. Okay, if it's not valid, you cannot use integration by substitution. Okay, so let's take a look at the another example. Okay. Oh, by the way, they will show you the substitution you need to use. Okay, so that means it's quite friendly. Okay, so let's pick one question. So we are moving on to G. So by the way, do you think your graduation will get delayed because of this?
We're questioning the possibility of a graduation ceremony.
Yeah. Okay. Graduation ceremony can be cancelled, but what about your date of graduation?
What do you mean?
I mean, graduation, you can graduate without the graduation ceremony, right?
Yeah, of course. It'd be mailed home.
So
I mean, I don't really need it. I don't really need it. I have a university.
okay, but do you think you can graduate? But if you can't graduate, that means you can't go on to your university, right? Can you?
I mean, I can.
You can?
Yeah.
Because of this situation, when is your you're not going to take your final exam, right? They'll just take your usual assessment.
Yeah.
Right? Okay, good. So now it makes sense, right? You don't need a graduation ceremony. Okay. Okay. Anyway, yeah. Let's continue from here. Okay, let's take this example. Okay. So what it means is, take this as your substitution. So this whole thing, before I do the substitution, I need to differentiate this u x first. Okay. So I get what? I said cosine x, right? Okay. So now you just replace. So can you see that your du dx is equal to cosine x? Can you see that?
Yeah.
Yeah. So therefore, you replace your cosine x with du dx.
Right.
Okay. So you just copy the rest, and now this sine x is replaced by ux. So this sine to the power of 4x is actually u to the power of 4. Okay. So all you need to do is you will end up integrating. Integrating this. So power plus 1, bring down the resultant power plus c. So replace your u with your sine x. Simple?
Yeah.
Okay, so integration by substitution is quite simple. Okay, so let me pass on to you to try out question B.
Okay.
Okay.
We can have this page on.
Yeah, I will get it to the next blank slide.
No, I want the process. I want to see.
Oh, okay. Then I will just leave this. Okay.
The B, right?
Yeah.
All right.
Question B.
U form D, so it is free form.
Are you done?
Yeah.
Hmm?
Yes.
Okay, it's okay. Let me just demo. Yeah, and then you just compare the answer. Okay. So over here, the question is quite friendly because they already tell you what substitution you need to use. So you have your ux equals to x3, x to the power 3 plus 1. So your du dx is 3x to the power 2. That's it. Am I right? Now, you just look at this. Okay. Can you see that?
Yeah.
Can you see that your this so that means what? That means over here you have your x squared, right? So your du dx, okay?
Yeah.
1/3 of your du dx is equal to x squared.
Yeah.
So therefore, you can actually change your x squared into 1/3 du dx. Okay?
Okay.
So therefore, you just, so x to the power of 3 plus 1 is replaced by u. Okay? So just copy the rest. So which means your x squared, right, is replaced by this. Okay?
Yeah.
Which is given by this. And then your this x to the power of 3 plus 1, okay, is given by u, right? So now what you do is you take out the 1/3 and just integrate this. And then what do you get? E to the power of u, you should get e to the power of u. Okay? And then that's it. Okay? And then of course you need to replace your u with this one.
Right.
And then this is your final answer.
Okay.
Yeah, pretty simple. Okay? So yeah, so today I think we have learned something new. Okay? So
Yeah.
what did we learn today? So besides the three methods of integration, term by term, and then chain rule, and last but not least, partial fraction, and then term by term. So
Yeah.
we have learned this last time. Okay. Today we learn 2 more. Okay. So when it comes to trigo to the power of more than 1, you need to use identity.
Right.
Okay, identity. And then the last one is integration by substitution.
Right.
Okay? So these are the methods we have learned so far, okay, to do integration. Okay, and we also see how the graph function is linked to the gradient function.
Right.
Okay, you differentiate to get your gradient function. So gradient function to graph function, you integrate. Okay, so this is the summary of what we have learned so far. Okay,
Right.
Any other question?
No.
Okay, if not, then I will end the lesson here.
Okay.
Okay, so thank you very much.
Okay.
Yeah, we'll see you next week.
See you next week.
Bye bye.
All right.